Okay, today we're going to begin theoretical probability. In this section, you're going to be able to estimate probability using theoretical methods. Starting off, as usual, here's the vocabulary. Going to take a minute to copy that down. Okay. All right, starting off, we're going to calculate theoretical probability. An experiment consists of rolling a fair die. There are 6 possible outcomes, which are 1, 2, 3, 4, 5, and 6. So, just like a number cube, if you roll it, those are your possibility. That's your sample space. All right, so the first thing we want to find is the probability of rolling a 3. Now, it's almost like experimental probability, but in this one, it's assuming everything has a fair chance. So the first one, probability of rolling a 3, you will write it as probability, but to help you out, I want you to write the word 3. Because a lot of times if you put the number 3, you think that the probability is 3. So to make it easier for you so that you don't make quick rash decisions, write the number of the word. So the probability of a 3. Now we look at our sample space and we have a total of 6 outcomes. There are 6 possible outcomes. Of those 6 outcomes, how many of them are 3? There's only one outcome that says 3. So the probability would be 1/6. So in theoretical probability, it's assuming everything has a fair chance. So you have your total, just like an experimental probability, you have your total of 6 outcomes, but how many of them are 3? And that is only one. Again, I want you to write the word 3, because sometimes you might just think 3 and automatically put a 3 over 6, which we do not want you to do. So in this next one, probability of getting an odd number. So in this one, the total is 6, our denominator is 6, but we want the odd numbers, and the odd numbers are 1, 3, and 5. How many numbers do we have? We have 3 numbers. And you simplify this to become 1/2. So the probability of rolling an odd number is 1/2. And then the probability of rolling a number less than 5. So again, you want to write it less than 5. Whoa, don't know what that was. 5. And again, we have a total of 6 outcomes, but how many of them are less than 5? This one, this one, this one, and this one, which are 4 numbers, and you're going to reduce to 2/3. So the probability of rolling less than 5 is 2/3. So in theoretical probability, just like with experimental, your denominator is going to be your total number of outcomes. But the top is how many that they're looking for. All right, in this one, we're going to calculate the theoretical probability of 2 fair die. So this time, it's not just one number cube, it's 2 of them this time. So the first thing we're going to do is show the sample space that has all outcomes equally likely. In this one, I'm going to go to this page over here. So again, remember, we have 2 number cubes this time. So when you roll them, what are all the possibilities you can get? One would be 1/1, another would be 1/2, another would be 1/3, 1/4, 1/5, and 1/6. So this one is saying if we have the number cube, if the first cube we roll a 1, the second cube I could roll a 1. The first cube is a 1, the second one it could be a 2. 1/3, 1/4, 1/5, and 1/6. doing the same thing. If the first one was a 2 and the second one was a 1, you can also have 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. You could have 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. With the 4s, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, and 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, and 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So that would be your sample space. If you have 2 fair die, those are all the possibilities you can get. Okay, well, let me go back for a minute. Now, when you look at this sample space, we're going to use this sample space to answer the questions that come after this. But first off, how many total outcomes do we have here? If you count them all, you will see that we have a total of 36 outcomes. One way, you can actually count them, 1, 2, 3, 4, 5, 6, all the way through, or we have 6 going down, 6 across. We know there's a total of 36 outcomes. But we know the total is 36. So whenever they ask what is the probability of rolling 2 even numbers, probability of 2 evens, when we go over here, we look for 2 evens. All of these are odds. The first number is 2. So we got 2, 2, 2, 4, and 2, 6. There's 3. 4, 2, 4, 4, 4, 6. There's 3 more. 6, 2, 6, 4, 6, 6. There's 3 more. So we will write it as the probability of 2 evens are 9, because we found 9, out of a total of 36. And this number does simplify. 9 goes into 9 one time. 9 goes into 36 4 times. So the probability is 1/4. Now I want you to use that sample space to find the probability of rolling 2 5s, and then the probability that the sum of the two numbers will be greater than 8. So the sum is greater than 8. Again, use that sample space we just did. All right. So if you went to your sample space, we know there's a total of 36 outcomes, but how many had 2 5s? There was only one of those. So your probability will be 1/36. Over here, probability that the sum is greater than 8. So that tells you want the numbers that are greater than 8, which are 9 and up. So when you go over here, you want the numbers that you add together, such as 3 plus 6 is 9. That's one of them that we want. But 3 plus 5 is 8. Remember, we want more than that. So we know this is 10. That's 9. That's 8. We're going to stop there. That's 11, 10, 9, 8. That's not one of them. 12, 11, 10, 9, 8. Stop there. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those numbers that add together to get more than 8. So you have your fraction, which is 10 over a total of 36. And when you simplify, divide by 2, you get 5/18.